All right, one of the most important things that we do when we look at functions, and a function is something like a parabola, y equals x squared, or an absolute value function, y equals the absolute value of x. Anytime we look at those equations and we're graphing them, we have some characteristics that we look for that are important. And you might have heard some of these words before. We're going to look for things like domain and range. We're going to look for increasing and decreasing intervals. We're going to look for the vertex. We're going to look for maximums and minimums of the graph. We're going to look for x and y intercepts. So one of the big things we do in Math 3 is we get really good at finding these, and we get really good at writing them in the correct notation. So the domain is defined as all of the x values which are the inputs, because you take numbers and you plug them in for x and then you get a y value as an answer. So this is all of the x values or inputs that are defined in the function. So what I mean by defined in the function is that you can plug those x values in into the function and get an answer. So when we do absolute value equations like we're starting with, you can plug any number into an absolute value equation. It just makes it positive. But you can think about equations you've maybe worked with before, like square roots. You're not allowed to square root a negative number. And so we would say that all the negative numbers are outside the domain of that function. If you think about fractions, you're not supposed to put 0 on the bottom of a fraction because then you're dividing by 0. So we're going to say that 0 is outside of the domain of a fraction. So when we think about domain, we're thinking about all the x values that you're allowed to plug into something. The range is all of the y values or outputs that are defined in the function. And so basically, these are all dependent on whatever number you plugged in. So basically this means these are the resulting numbers that you get. These are the y values you get after you plug all these x values in that were allowed. So basically this is the result you get after you plug the x values in. All right, so the big hint here to find the domain and the range easily is for the, we're going to look at the graph. That's what makes it easiest. So look at the graph. Domain is if you look at numbers from left to right, because that's the x's. So if you look at the graph from left to right, what are the x values that you can see on the graph? Those must be the numbers that plugged in and made valid answers. And then the range is going to be if you look up and down. So if you look up and down on the graph, if there's a y value that's missing, it means that there was no x value that could plug in to give you that y value. So now we're going to go ahead and look at a couple examples and see if we can look at the picture and look at the equation and figure out what the domain and the range are. So this is an example of a graph that we have looked at today. And if you look at this graph, you can see a normal absolute value graph would start at 0, 0. And this absolute value graph has moved to the right 1, 2, 3, 4 places. So if I was to write the equation for this, I'm going to have x minus 4 inside the absolute value signs because it's always the opposite of what I would think. And I can see that the vertex has moved down 1. So I'm going to see a minus 1 on the end. And then for me to figure out if there's a stretch or a compression here, I just need to see how far down it goes when I go over one box. So over one box makes it look like it goes down 3. So that means that this graph has a stretch of 3. And because the graph is upside down, I know that this is a negative graph. It's been reflected over the x-axis. So for me to do the domain and the range on this graph, I have to think about, for the domain, what are the x values that I'm allowed to plug in? And what I already described as I was saying what domain meant is that the x values that you're allowed to plug in would only be limited by something like having a square root in the function or having a fraction in the function or something like that. We've never had a reason to limit the numbers we can plug in for x. We just know that whatever you happen to plug into absolute value, it makes that number positive, always. So for the domain, we have two different ways to write it. We can say that all real numbers are allowed to be plugged in. That's one way of writing it. The other way of writing it is to say that every single number from negative infinity, the biggest negative number you can imagine, to positive infinity, the biggest positive number you can imagine, all of those numbers are allowed. So I would say negative infinity to positive infinity, like that. So two different ways of writing it. Now, the range is a little bit trickier, and typically you're going to get the range from the equation itself, or not from the equation, I'm sorry, from the graph, because from the equation itself you can't see a lot of information. So if you look at this, when I plug in every single x value possible, it looks like my y values don't go any bigger than -1. I can see all these negative y values down here. I can see that there's arrows, so I can tell that that graph goes down forever, but I don't see any y values that are bigger than -1. It just doesn't happen. So here we're going to say that the range of the numbers, the y coordinates that I'm going to see are y is less than or equal to -1. And I'm going to put that equal to sign because I can see there's a point where y is -1 exactly. The other notation, the other way to write this is to say that the y values range from negative infinity. So I can see that I'm going to have negative infinity for the y values because I have arrows going down. And those arrows are telling me that I have a value of -6 for y and a value of -7 for y, and -8, -9, -10, -11, -12, that this graph would go down forever. So it would have negative infinity all the way up to -1. All those y values between negative infinity and -1 would be included, but I don't have any y values that are bigger than -1. So this is the other way to write it. And we put a bracket right here. So what the bracket means is it's just like that equal to. We're saying not only can you get close to -1, you can actually have -1 exactly as a y value. And we will keep talking about domain and range because those are big ideas. So we're going to look at those with all the graphs that we end up doing. All right, for the second example, if I want to go ahead and write an equation for it, I have y equals. This time I can see that my vertex went to the right 4 again, so I still have x minus 4. And this time it looks like it went down 1, 2, 3 spaces. And if I look at this one to see if it's a stretch or a compression, it goes over 1 and up 2. So that would be a stretch of 2. And this graph is not upside down, and so I know that I'm going to go ahead and leave that as a positive 2 right there. So the domain for this one, again, there's no limit to the x values that I can plug in. So I'm going to say the domain is all real numbers. Or the other notation would be to say from negative infinity to positive infinity. And then if I look at the range, I'm not going to look at the equation because it's hard to see. So I'm going to look at the picture. I'm going to look at the graph. And if you look at the y values, you're going to notice that when I plug these x values in, I have all these positive numbers right here, but a lot of my negative numbers down here are missing. So I can see that as long as the y value is -3 or higher, that it's visible on the graph, or it would be visible on the graph if my graph was bigger. But if the y value is smaller than -3, it's not going to show up. So with this notation, I'm going to say my range is anything greater than or equal to -3. And over here, I'm going to describe my range as being -3, -2, -1, 0, 1, 2, 3, and then all the way off into infinity. So I'm going to say the very lowest value that my range could be is -3. And then I have all the positive numbers all the way up to infinity. And again, we put a bracket around -3 because I can see right here the graph actually hits -3.